Exercise 9F, Perpetuities. Perpetuities are the equivalent of an interest-only loan, but instead of paying interest only, you're earning interest only. So the idea, as you can gather from the name perpetual, is that it should last forever. This is if I made an investment and I'm living off that beautiful interest money, the original investment stays there. So theoretically, a perpetuity can go on forever. And that's another little trap question. How long can this perpetuity last for? It lasts forever. So when I'm using the financial solver, the FV, when I'm calculating the final value, should be the same as the principal. The only issue is that because I'm investing the money, the PV, the principal value is going to be negative because I put in the money, and then the final value, the future value, will be positive because I'm still getting that money, so I'm still earning that money. So let's go and have a look at what this actually means. So using a recurrence relation, we can still go and find out how much we earn via perpetuity. So it's still R, capital R times by Vn, take away D. The R is still 1 plus little r over 100, and little r is still the interest rate divided by the number of compounds per year. The D value is finding the interest, so it's the little r over 100 times by V naught. So in other words, it is, again, almost very linear again, but because the original amount is not really growing by any amount because we're constantly just taking away the interest. So let's go and have a look at some problems relating to this. Example 9F.1, this is from the Northern Hemisphere timetable, exam 2. Julie is retired from work and has received a superannuation payment of $492,800 and intends to invest it in a perpetuity. She would then receive $887.04 each fortnight for the rest of her life. At what annual percentage rate is earned by this perpetuity? So again, what we'll need to do is we'll need to use the financial solver. So we've got the N value to deal with here. So that's the first thing we need to work out. It's fortnightly. So we're finding out how much we're getting per fortnight. So how many fortnights are there in a year? Of course, there's 26 fortnights in a year. And it looks like now, is there any reference to any different compounding? No, so we're going to assume that the payments per year are 26, and the compounds per year are also 26. The interest rate here, that's the thing we need to work out. The amount that she invests in is that PV value, so that's going to be $492,800. You'll notice that there I've put that as a negative value because she's put it into the perpetuity, so she's given the money, so that's going to be a negative value. She would receive a payment of $887.04, so she gets that, so that's going to be a positive number. And the future value is still that original amount that she's put in, so that's $492,800. So now what we're going to do is work out the percentage rate accordingly, and I get there as 4.68%. Example 9F.2. Which one of the following recurrence relations could be used to model the value of a perpetuity investment P0 after n months? So first things first, let's have a look at the different options and see if there's anything we can eliminate. The first thing to be reminded is that the capital R value is 1 plus little r over 100. So that means if there's any options that are less than 1, it's automatically wrong. So we can actually get rid of D and E because they are less than 1. So it must be out of the first 3 options. So how can we work out which one is equal to the P0? So if you remember that capital R is equal to 1 plus little r over 100, and we know that for a perpetuity, D, the money that I'm taking away, has to be equal to little r over 100 times by V naught, or the initial amount, all we need to do to check is to see if we did R, take away 1, because that's what that's the difference, and times it by V naught, we should see which one we'll be able to determine which one is the correct D value. And a reminder, the D value is these little friends at the end. So they're the D values, and there's the V naught, or in this case, P naught, as the question might be. For this one, I don't even need to use the financial solver. We could actually just chuck this into the main screen of the CAS, and we can do a little comparison. So all I'm going to do is I'm going to do the R values, take away 1, and then sort which one's out. So first thing I'm going to do is we'll try A, 1.0036, take away 1, and I'm going to put that in a little bracket, and we'll times that by the P naught, which is $240,000. So that looks like the correct answer. Let's go and make sure that B and C don't come up with something similar. So B is 1.0024, take away 1, times by its P naught, which is 120,000. So no, the 288 is not 348, so I can eliminate B. And C is 1.0046, take away 1, times by $250,000, and that gets me 1,150, so we can eliminate C. The answer is indeed A.